In this lecture, we'll be talking about floods, how we measure them, and how likely they are over time. First, what is a flood? A flood is when a stream has too much water to hold in its channel. In the picture above me, taken in the middle of the Australian outback, the Todd River is flooding. An easy clue is that the water extends into the trees on either side of the channel. These trees grow on the floodplain. Here's the same flood a day or two later. Here you can clearly see that the water is occupying places where it isn't normally. This park in Alice Springs is built on the floodplain. A floodplain is an area of low-lying ground adjacent to the river, formed mainly of river sediments and subject to flooding. Here's the same picture the next day. The floodplain has dried out and the river is back in its channel in the far right of the photo. The flood is over. What does a floodplain look like on a map and a little bit closer to home? Here's a map of the Cuyahoga River Valley between Peninsula at the bottom of the screen and Boston near the top. If you've ever driven into the Cuyahoga Valley National Park, then you know you go down a steep hill and enter a flat area as you get near the river. I've outlined that flat area, the floodplain, on this map with black lines. For proof that the Cuyahoga River floodplain is subject to flooding, we can look at the photo at the top above me. It's the aftermath of the 1913 flood in Boston. The 1913 flood was the largest recorded flood on the Cuyahoga River and in much of Ohio. The Cuyahoga floodplain still gets flooded, as shown in the picture directly above me of the trailhead parking area near Peninsula in 2011. What we choose to build in the floodplain affects the flood risks that we experience. Where the Cuyahoga floodplain is now completely contained within parklands, there is not much damage or economic cost from the flooding. But where we build roads, houses, and towns within the park, the consequences of the same flooding become more severe. Let's talk about how we measure floods. To hydrologists, a flood is any time there is more water than the channel can hold and the river starts to overflow its banks. Hydrologists call the very largest amount of water that the channel can hold the bank full stage. But if some water spills onto the floodplain and there's no risk to human life or property, most people don't care. So we also define a flood stage, which is the height above which a rise in water level begins to create a flood hazard, damaging property or creating a risk to life. The U.S. Geological Survey operates stream gauging stations that record water height, that we call stage, and discharge, remember the volume of water flowing past a point in a given amount of time. So channel shape affects the stage or water height, but not the discharge. The National Weather Service then uses the USGS stage and discharge data along with weather forecasts to issue flood advisories and flood warnings. If you care about whether your house will get wet, you want to know river stage. If you care about how much water a river has, you want to know discharge. Both are useful. Regardless of what you are measuring, some floods are bigger than others, and bigger floods don't happen as often as smaller floods. But bigger floods cause more damage and risk to life, so we care about them a lot. We want to know how often a flood of a particular size is likely to occur. In other words, what is the probability of a certain size flood? In order to calculate the probability of a particular size flood, we turn to the historic record of flooding along a river, and we use a graph like the one shown on the left. We use statistics to assign a probability to each flood in the historic record, and then fit a line to the points. That lets us estimate the probability of a particular flood for any one year in the future. That means that we can do things like figure out the flood that has a 10% chance of occurring on the Tar River in North Carolina, which is the graph shown here. Reading off the graph, there is a 10% probability that the river will experience a flood of 25,000 cubic feet per second or higher next year. You may not be used to hearing people talk about floods in terms of probabilities, but you may be familiar with the terms 100-year flood or 500-year flood. Those terms are also used for determining whether your home lies in a floodplain where you need flood insurance. 100-year floods and 500-year floods are flipping probability on its head and expressing it as a recurrence interval. The recurrence interval is the average length of time between floods of a given size or magnitude. The table shows how every recurrence interval has an associated probability. Nowadays, hydrologists don't like to talk about floods in terms of recurrence intervals because it can be confusing and give people a false sense of security. The two big floods can't happen on the same river with only a few years apart. Instead, we talk about probability of chance in each year. Hopefully, when we do that, you get the idea of floods as independent events. Think about rolling the dice. You have a 1 in 6 chance of rolling a 6. But if you roll a 6 in one turn, you still have a 1 in 6 chance of rolling it again on the next turn. The same thing is true of floods. I think this is one of the most important things you can come out of this class knowing. So let's try an example multiple choice question. If you live in an area that was flooded by the 100-year flood last year, you can conclude that A, the next 100-year flood will occur in exactly 100 years. B, the next 100-year flood will occur in exactly 99 years. C, there's a small chance that you could be flooded by a 100-year flood again this year. Or D, you don't have to worry about another flood of that size during your lifetime. Hopefully, you all answered C. There's a small chance that you could be flooded by a 100-year flood again this year. Let's use a real-life example. The pictures show a small town affected by flooding along the Mississippi River in 1993. The 1993 flood was widely considered to be at least a 100-year flood along this part of the river. But as you can see from the right-hand photo, the town was again affected by flooding in 2001, and also 1997, by the way. Can you spot the blue swimming pool in both photos? The moral of this story is not to confuse recurrence interval with the idea of safety because a big flood happened recently. Remember, it's a new roll of the dice next year. When an extreme flood happens somewhere, you will hear lots of news reports talking about it being a 500-year flood or even a 1,000-year flood. But I want you to use caution with those numbers. We rarely have more than 100 years of data for rivers in the US, so when we're talking about events with recurrence intervals longer than that, or probability lower than that, we're talking beyond the data we have. Take extreme numbers as approximations of risk, not absolutes. When we are calculating flood probabilities, we also don't take into account the effects of humans on the size and frequency of floods. Land use and climate change can both alter the probability of a particular size flood. In the next lecture, we'll talk about different types of floods and the natural and human factors that influence them.